mentioned, a bunch of us, actually, I mostly moved to with Richard Epstein, who was then at Hebrew University. He's a geneticist, and we were collaborating when I was in Hong Kong University of Science and Technology. After moving there, we started building up this group, and the red-colored names are contributing to this presentation. Obviously, decision-making is a complex system of sorts, involving the contributions of all the way from genes through neurotransmitters and hormones to brain activation, which presumably lead to decisions. And clearly, this is a systemic approach because we do not have a total micro model. Here, you can already see the role of conscious versus unconscious, system 2 versus system 1. And it is probably a good idea to bring system thinking to model the decision maker beyond the kind of economic, homo economicus, classically speaking, and recognize that we are all biological beings. And Raymond was talking about how Rafer would be open to, first of all, behavioral considerations, and more broadly, and maybe deeply, biological considerations as well. Here are yet two more complex systems. A dopamine striatum system that are more reward-oriented, and a serotonin amygdala system that is more harm-oriented or harm-avoiding. I have this excitatory in red because, as it turns out, it is excitatory. Namely, our enjoyment and our worries are involve action at the neuronal level. Yet, I've just mentioned this. Let me go further. So long ago, well, like more than 200 years ago, William James, in a very insightful work, talked about emotion, quite distinct from what we were thinking, what were prevalent views. We tend to think in a Cartesian way, that it's like mind first. But if you're running from a bear, the alternative is you run first and you start feeling the fear. And this, of course, brought to us this notion of gut feeling. Gut feeling, as it turns out, corresponds to a part of the brain. First of all, if the guy is running from the bear first, you can imagine decision-making probably ought to admit the influence of your gut. Happily, we have an earlier talk in the previous session under Howard Rafer about the Damasio hypothesis, which is kind of a rejoinder of William James at the brain level. Particularly, the idea of the amygdala as an emotion brain has now received a lot of, has been somewhat validated. In a sense, we have two brains. The conscious brain is much more refined and deliberate, but the amygdala is often called the emotion brain, or also you can call it the gut brain, which is much more coarse. And if you smell danger, you should just react, stop everything. And you rather make type 2 errors. Okay. Here's a third system. There are lots of complex systems. It's a brake in our brain. So as I mentioned, the dopamine and the serotonin are excitatory in nature. And if you're worried and you don't have a brake, you might not be able to stop worrying, and there are those among us who are sort of that way. So those with strong GABAergic system can manage both you can't do anything about it, stop right now and resume worrying when the time is right. Or even in a casino, after some fun, you could say, it's time to go back to work. So we need the brakes. So Valium is especially in the US, right, is a common drug. It involves something called, well, it's in the class of benzodiazepines. And the functionality of Valium or benzodiazepine is actually to strengthen the GABA system. So precisely, there's a source of anxiety, sometimes all the way to depression, when people have weak GABAergic system. So you need to be, let's say, the assistance of a drug, a GABA agonist. Surprisingly, or maybe unsurprisingly, there's a drink sold at 7-Eleven in Singapore. As you know, Singapore is a super inner country, so if it's sold there, it's kind of safe. So it's a drink. It's like $3 US, and presumably it'll help you strengthen your system and you will sleep better. I mentioned this. Okay, so this is my very, very quick, under 5-minute intro for the rest of the talk. So in here is a 1921 insight of Keynes in his treatise on probability. I understand it was his senior undergraduate thesis before going on to his general theory and stuff. And here he actually already talked about how probability can be distinguished between just degree and confidence. So he famously wrote this sentence: if two probabilities are equal in degree, ought we not choose the one that is based on a greater body of knowledge? It actually sounds paradoxical. If two probabilities are equal in degree, shouldn't you be indifferent? But he then wrote a few pages before that statement something that really is this. Okay, so this is the famous, very, very famous Ellsberg-Tuven paradox, which actually first appeared in 40 years before Ellsberg published his paper. Ellsberg cites Keynes in his thesis, though not in the QJE paper. Of course, the Ellsberg paradox led to a huge literature, huge. Interestingly, it also led to a much smaller strand of literature. In 1995, Fox and Tversky has a paper in QJE about familiarity bias, but I'm going to describe our experiment inspired by Fox and Tversky. It's much easier, but you can look at the original paper. So our experiment involves 325 Beijing-based subjects. They bet on two even chance bets. Actually, there's not much to bet. They're just choosing between two bets without having to pay for it. So in one case, if they bet on Beijing temperature, either odd or even, published in Yahoo, randomly pick date to confirm after the experiment, they will know whether they win or lose. And it's basically an even chance bet. Should they choose Tokyo, then they win 2 yen more. Well, if you were to do an experiment just saying, hey, there are 2 coins, or the same coin, you toss it twice. First time pays 11, second time pays 13. I think that's the end of it. There's nothing to test, right? But this is Tokyo and Beijing temperature. Beijing subject. I don't want to spend time asking the audience, but presumably people should pick Tokyo. Turns out 60% pick Tokyo, but 40% pick Beijing. What's going on here? These are college-age, Beijing-based undergraduates. Oh, okay, by the way, this is essentially Fox and Tversky's 1995 paper. And I guess there's a point. Between 2 bets, equally likely, let's say same outcome, a person can be non-indifferent depending on the source of the uncertainty. And thus, if you strictly prefer one source to another, then you could, in fact, take a bet that pays less, connected with a source that you are somehow more comfortable with. So then another strand of thinking is the famous international home equity, home market bias, which was referred to in Fox and Tversky. So after doing their, let's say, individual choice study, in the sort of discussion part of the paper, they mentioned that possibly an individual disposition towards the unfamiliar in terms of choosing a familiar bet, could this be what is driving the home equity market, equity home market bias phenomenon in international finance? But of course, after the French and Poterba paper, there were lots and lots of papers showing that perhaps it can be explained through transaction costs, information asymmetry, taxation, blah, blah, blah. Nevertheless, 5 years after Fox and Tversky, there were two papers, one in Journal of Finance and one in Review of Financial Studies. The Journal of Finance paper, is very the name of the title is very instructive. Home market bias at home. So forget about international asymmetry, anything. And in the case of Huberman, I just listed his title for this talk. Familiarity breeds investment. Well, in particular, there are 7 baby bells, all split from the original big bell. And there's a tendency for people to invest in baby bells that are proximate to their locations. It's something that goes against the grain of financial or portfolio diversification, CAPM, blah, blah, blah. Okay, so here is a quick study about portfolio choice involving familiarity bias done at Max Planck. So subjects are endowed with 10,000 points, worth €10. We created 7 fictitious stocks with the first letter of the stock is like L, P, V, W, F, H. The last one is probably I, yeah. And we're looking at the stock, all traded in the bond exchange, tomorrow, the next business day, market closing, and it's all reported to 2 decimal places, the last digit, whether it's an odd or even number. So this is the task. The experimental task, they're given 10,000 points, and they can not invest and just have 10,000 points, €10, or they can put in a number of points. They want to invest in up to 3 stocks, and put down the number of points and put down whether they bet even or odd. Now notice that of the 7 stocks, 4 of them pay 2.5 and 3 pay 2.7. What's the meaning of 2.5? It means that if you guess correctly, the investment is multiplied by R. If not, it's 0. So it's all, basically it's a positive expected gain. But 3 of them have definitely more positive gain than the other 4. If you look at the design, you can only pick 3. So what would you do? It's a no-brainer. It's not rocket science. You're supposed to pick only among those 3, 2.7. And given that these are independent or at least uncorrelated events, you might, if you are the usual diversifying type, you will just diversify among 3, or else you don't invest at all, which is also cool. So this would be the theoretical prediction. Only the 2.7 will be purchased, but this will call them experimental error. Now, I review to you what the letters represent, right? From Volkswagen, Flyderer, IVG, Lufthansa, Homek, Puma, Wacker. For people who, I didn't know about it, but apparently Wacker is a very familiar, it's almost like IKEA for Germany. So, which has the highest demand? Okay, this one we can allow ourselves 5 seconds. Which one has the highest demand? Yes! But of course, this is before the scandal. Okay, this is the demand. Volkswagen, number 1. Wacker, number 2. Puma, number 3. Lufthansa, which is not the most appealing airline, but still, more so than the 3 that are 2.7. The 2.7 behaves like standard CAPM, essentially equal. You don't know what they are, but you know there is going to be half chance and independent. So what is going on? Well, first of all, just to summarize, people who only pick 2.7, 36%. The rest of them have at least some 2.5. Okay, time to link decision theory with choice bias of a sort, but of choice preference, disposition, familiarity bias, person biology, and discussion of the role of the unconscious. And what do we learn from the two experiments? Actually, we learned something very stark. Actually, it's a lesson in Keynes. Keynes already said it. If two events have the same probability, it doesn't mean that they are treated the same by real people. So he's almost like the original behavioral economist in 1921. In that spirit, so in that case, what are we going to do from the theory point of view? In other words, we cannot count on objective probability as a guide for treating events the same, because it's not same enough, all right? So what can we do? How about we just take experiment to provide for the theoretical foundation? Two events are only equally likely in the strong sense if you treat them the same. So objective probability is not enough. I'm just saying it 3 times, 4 times, 5 times. So why don't we just have a proper definition? And it says, this is just a very quick way of saying, if two events are exchangeable, that means you do not care how you associate outcome with them, regardless of the overall act and the pair of outcomes concerned. Once you have an exchangeability definition of equally likely, it's easy to define more likely. It's a binary relation. So E is more likely than E prime, E is more likely than E prime if E contains a sub-event that is equally likely. And of course, then the question is the likelihood relation a complete one? If you're going to try to axiomatize probabilistically sophisticated behavior, that means in all decisions that you make, you try to assign probability in a consistent way. Of course, you want to have completeness in the binary relation, the likelihood binary relation. But the evidence that we've just seen tells you that human beings may not have complete likelihood relation, in which case then we don't complete. So you can either complete or don't complete. I'm going to be fast-forwarding. So if you complete and you add 2 more axioms, you can actually get a global probabilistic sophistication axiomatization. With Jacob, Sergey, and I published this in Econometrica in 2006. But this is not satisfactory because we want to really capture real human behavior. So what we did is we dropped completeness, strengthened one of the auxiliary axioms, and we published the lead article in 2008 in JET, and we call this a small world. Namely, Beijing temperature is a small world. All the digits are treated the same. Tokyo temperature is a small world. Depending on the subject, some might commute the two into a bigger, small world, but for some, not necessary. Okay, so the immediate deliverable of this approach is something called, in the special case of expected utility, we can then have source-dependent Poterba-Morgenstern utility. For instance, like this. This is your typical CRRA utility. This is the source of your uncertainty. It could be half chance. So this is classical. This is not classical. If the index, the curvature of the utility function itself, is a function of the source, then it's not classical. So this we call it source-dependent expected utility. Now, this is time. With the remaining, I'm controlling time. I've got 6 minutes. In the remaining time, I will then go into the subject proper. Namely, how can we show this? Well, to show this, you have seen the GABA system. Probably we want to find a gene in the GABA system, and in particular this gene. And the hypothesis is itself a systemic hypothesis because there are 3 components. There are genes, there's a brain that presumably makes decisions, and there's familiarity bias, which is observable choice behavior. So we are interested in linking gene and decision. We are also interested in brain as the intermediary through the amygdala. We have seen this before, okay? Here is a very, if you don't know it, it's no big deal. Basically, in the brain, there are about 20 million useful such variants. They just call it SNP. And in the SNP, In a human DNA, there are a bunch of genetic DNA letters. They are like A, G, and CT. And the notation of major and minor is a pure descriptive statistic statement. You take any pair in any location of the DNA, surely one of the letters is more than 50% prevalent, and the other is less than 50% prevalent. So that's the meaning of major and minor. And in terms of type, as it turns out for this study, for GABA, mostly we're looking at something called the dominance model. So it's like either there's minor or no minor. If no minor, both major. Otherwise, at least one minor. So there are two major types, with or without minor. Okay. Our collaborator at HKUST, her name is Soo Hong, and she's a biochemist. Her lab specializes in GABA plus schizophrenia, and it's a natural thing for us to collaborate because she's not doing cancer or diabetes. Okay, it's schizophrenia somehow connected with the mind. But she was very pessimistic that we'll see anything. We had no reason to be pessimistic or optimistic, but we just collaborated. As it turns out, of the 10 SNPs, I didn't want to review the ID of the SNPs. There are 10 of them, but these are 10 that came up in the schizophrenic literature, and 7 of them were in principle associated with the tendency to bet either the familiar, which is Beijing, or unfamiliar, which is Tokyo. And to do something more precise, we did something called a genetic load analysis. So every subject has 7. Of course, all of us has those 7. The question is, are you a minor or not a minor? And you can see, people who are no minor, 0 minor, the fraction betting Beijing is actually half. It turns out to be exactly half. People who have only got minor, is actually, the odds ratio is below 0.4, so the probability is probably 0.3. So there is a kind of a declining relationship, depending on how many of those 7 SNPs, let's say, are minor for you. Okay, so this is our in principle, 3 minutes, okay? In principle, link between behavior and gene. The next thing is to establish gene, brain, and behavior. So for that, we chose 37 subjects out of the 325. We know these 37 subjects, whether they are minor or major. They don't know themselves. And the experiment, the scanning experiment is really super, no fanfare, no song and dance. It's black background, white lettering. Why? Because it's money, okay? Pay attention at money. So the conscious part is money. And first, you look at the city name, one of these Chinese cities, all domestic, and then you look at the amount connected with it. So we are always betting odd temperature because in a scanner, you don't want to have movement, unnecessary movement. It's always odd. Or else you can always pick the certain amount that follow within seconds. And this is done 80 times, 20 cities. We do an estimation using this CRRA with a familiarity-dependent index, or kind of curvature. So, and when we tested that, okay, this is like, a model in which the index is a linear function of familiarity. When we tested it, we didn't get significance for R1, suggesting that expected utility garden variety CRRA is good enough description of the data. But we haven't used our genotype information. So when we put in a gene dummy, turns out exactly the gene dummy for sensitivity to familiarity is significant. So we established now, surprisingly, from 325 subjects, we scaled it down to 37 subjects, we still get the behavioral result. But beyond that, okay, first of all, you can see, the conscious processing system 2 is looking at the amount of money, but the unconscious processing is actually in familiarity rating done subsequent to scanning. You see, this is subsequent scanning, but during scanning it's happening because it matters to you whether you know the city or not, whether you grew up there. All right. So very quickly, we have a standard finding. Wow, 20 seconds. Okay, so the reassuring finding is our utility function does correlate with striatal activation, which is reward processing. The nice finding is amygdala. We found that amygdala activation predicts the degree of familiarity bias, and it's predicted by genotype. Now, this is very simple intuition. If you are the anxious type, then your amygdala activation will be high, and in order to ameliorate that, you pick familiarity. If you have weak GABA, well, again, you need to pick familiar in order to not experience the anxiety. This is just the usual brain picture. Good. I have about maybe 10 seconds. Oh, in fact, time's up. So we established a gene-brain we managed to support a gene-brain decision hypothesis in which the particular minor allele we studied is under positive selection. That means the human species has been getting into this stuff, maybe become more trusting, more reliant on market institutions. And also, it itself has a functionality as an agonist for GABA. Thus, this offers a cause for the familiarity bias, plus there's a natural pharmacological intervention study following. And I just want to sell this, right? It's not every day that a single SNP change can have implication all the way to the market and potentially global financial market. Okay, thank you.